is Academic Decathlon Review Sheet number 10. We are going to work with congruency. So we're going to do a little geometry work here. It says triangle DEF has the coordinates D at -1, 3, -1, 3. Oh, let's get our pen working. -1, 3. E is 2, 2. And F is 4, 2, 3, 4, -8. So that is F, this is E, and this is D. That is an interesting triangle, but we will draw it and connect those dots. So we have triangle DEF. Some transformation has been made to each point and resulted in D prime. That little exclamation or that apostrophe is called D prime. D prime is at -1, -3, -1, 1, 2, 3. So that's D prime. E prime is 2, -2, 2, 1, 2. Okay. And that is E prime. And F prime is at 4, 8. Whoa! 4, 8. Wowzers. That's a major. And that is F prime. Okay. Let's connect the dots. Let's make them blue so we can see that. And that now looks like that. So I'm going to assume that that was reflected. Yes, I'm going to say, are these two triangles congruent? Yes, they are. They are congruent, and some transformation. It looks like it's been reflected over the x-axis, meaning we have a dotted line. We have a reflection. I don't want that, but I do want red. That we have a reflection over the x-axis, meaning each point was rotated over that x-axis. It is 3 away from the x-axis. D is 3 away. D prime is 3 away. E is 2 away. E prime is 2 away. And F is 8 away, and F prime is 8 away. So it looks like it reflected over the x-axis. Yes, they are congruent. Congruent. And was reflected over the x-axis. Or if we had to write an equation for this line, that line would be y equals 0. It was reflected over y equals 0. If you want to get really technical, that line can be written as y equals 0. Yeah, I don't know if you have to go into that much detail, but we'll see. But that's a good thing. So triangle ABC has coordinates -1, 3. Hey, I've heard of that before. That is A is 2, 2. Hey, I've seen this one before. And 4, -8. Huh. We've seen these very similar. Let's draw. This is the original triangle ABC. Gotcha. Move each point up 2 and to the right 1. What are the new coordinates? Okay, that's nice and fun and easy. Let's do purple. So up 2 and to the right 1. Up 2, right 1 is now A prime. Up 2, right 1. Can I move this? Yes. So let's go back to that. Up 2, 1, 2, right 1 is going to be B prime. And up 2, right 1 is going to be C prime. Oh. It's going to be C. So the new coordinate, let's connect them because we're good, because we want to be proficient. Connecting, so we have this triangle and the coordinates. So we would write them like this. A prime is 0, comma, 1, 2, 3, 4, 5. B prime is going to be 1, 2, 3, 1, 2, 3, 4, so 3, 4. And C prime is going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So 5, negative 6. Those would be the coordinates for each of the new. And that shift, right, I think you write it in this manner. You would be x plus 1 and y plus 2 would be the translation. Up 2 and to the right 1, yeah. So right is on the x-axis, up is on the y-axis. I don't know if you have to write that, but that is the translation. What is the line that point A moved along to create point A prime? What is the line that it moved along? What is the line that point A moved to create the point A? So if we create a line, okay, I get it. I didn't understand it at first, but I think I get it now. So what they're saying is, hey, what is this? Let's go yellow. What is the line that moved along? Ooh. So that has a slope of up to right 1 and a y-intercept of 1, 2, 3, 4, 5. So this has a slope of up to right 1 and a y-intercept of 5, I thought I said. What was it, 5? 5? 1, 2, 3, 4, 5. Yeah, 5. So slope-intercept. So when you use the formula y equals mx plus b, we know my slope is 2 and my y-intercept is 5. So the line that it moved is 2x plus 5. I like that. That sounds very good. What is the line that point B moves along to create point B? Okay, so B isn't going to be it's going to have the same slope. It's just going to cross the y-intercept at a different location. So let's draw this one. So still here, let's draw another color. That's interesting. Slope of 2. So, you know, it's going to be like that. So it looks like it's negative 2. We could just go down 2, left 1, down 2, left 1. Yeah, I mean, I would say negative 2. Negative 2? Sure, let's try negative 2. So still has a slope of 2, but the y-intercept this time is negative 2, so we'd say y equals 2x minus 2. That sounds about reasonable. And then what is the line that C moved to create C prime? So C, oosh. All right, so C prime, slope's still 2. Let's do the old rickety way. Down 2, right 1, 1, 2, left 1, sorry. Down 2, left 1, down 2 will take us to the intercept. So how many did we go down? We went down 1, 2, no, we went down, sorry, so this is 10, this is 10, negative 10, 11, 12, 13, 14, 15, 16. I'm going to say that that's negative 16. So I'm going to say the slope is still 2 and the y-intercept is negative 16. That's going to be the easiest way. So I'd say y equals 2x minus 16. Now we can plug in both of those points into that equation and they should be true. So they should end up being there. So we can take this value, 4, negative 8, and 5, negative 6. 4, negative 8, I think it was. What was it? 4, negative 8? And 5, 4, negative 8, and 5, negative 6. 5, negative 6. If we plug those x values into this, so y equals 2 times 4 minus 16, which is 8 minus 16, which is negative 8. That checks off. And y equals 2 times 5 minus 16, 10 minus 16 is negative 6. So that's another way that we can go about making sure that this equation represents those points, which it does. That's pretty good. What is the same about the lines from 3 to 5? What is the same? Well, the slope is the same. The slope is going to be the same. Slope is the same. And they are parallel because we know lines that have the same slope are going to be parallel. So if we had to draw that little doozy just to lock it in, let's draw those points. Yes, all those are have the same slope, and that sort of off by a little bit. Is that no? I want to go that point. I think that's the point. Those are the points. So something like that. Those three lines, yellow, lime green, and hunter green, all look like they are parallel to each other because they have the same slope, up to right 1. They are parallel because they have different intercepts. The same slope is the same, different y-intercepts. Why do we have to say different y-intercepts? Because if they had the same y-intercept, then they would be the same lines. So they would have to. Triangle ABC has coordinates at A, B, and C. Some transformation has been made to each point and resulted in A prime, B prime, C prime. Are these two triangles congruent? So let's draw those first points. Negative 6, 1, 2, 3, 4, 5, 6, 1, 3 would be A. B is negative 2, 2. That's going to be B. And C is 4, negative 8. 1, 2, 3, oh, hello. 4, negative 8. Let's see. Let's connect them. Good. And some transformation has been made to create 6, negative 9. 6, yikes, 1, 2, 3, let's 1, 2, 3, 4, 5, 6, negative 9 is going to be A prime. B prime is 2, 6. 1, 2, 3, 4, 5, 6 is going to be B prime. And C prime is negative 4, negative 24. Yowzers, that's way the heck down here. So 1, 2, 3, 4, way down here is going to be C prime. Let's connect the dots, and I'm going to go out on a wild guess and say that they are not congruent. I'm saying they're not congruent, maybe, because the distances look, because the shape looks completely different. But let's look and see. And here's the way that we can look is the transformation that, so, yeah, see, B got shifted 1, 2, 3, 4, 1, 2, 3, 4. It's up 4, right 4. But then A didn't go up, it went down. And C went down and went down more. So I'm going to say no. They have dilated as well as reflected over the y-axis. The reflection maintains congruency, but the dilation does not. So, okay, where did they reflect? They reflected over the y-axis, meaning B was on the left side, now it's on the right side. A was on the left side, A prime is now on the right side. C was on the right side, and now it's on the left side. C prime is on the left side. But the dilation, meaning the stretch or the growth, is not consistent. Yeah, I would concur. I'm going to say no also. No. So let's look at the reflection over the y-axis. So that went 2, that went 2. A is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And C was 1, 2, 3, 4. And C here is 1, 2, 4. Okay, yeah. So it did reflect correctly over the y-axis. So that's good to know. So it did reflect properly. So it did reflect here properly. It just didn't grow. The stretch went from 2, 1, right? So the A didn't stretch as much as proportionally. B, the y-axis, you went 1. Nope, sorry, didn't mean to do that. Let's show what I mean by that. Meaning B to B prime is 1, 2, 3, 4. And A went from went 1, 2, 3, 4, 5, 6, and then C went some crazy to 24, and it was at 1, 2, 3, 4, 5, 6, 7, 8. 8 to 24 is going to be 8 to 24 is going to be, what's that, 18? $16. Sorry. 16, and that's not proportional either. So, yeah, so just things. Transformations, these are the warm-up problems following the rule X. Yeah, so here's that rule that we were talking about. So when you plug in 3 for X and -4 for Y, what's that new coordinate? Is going to be 6, -6 would be your whatever, that's your prime, that's your new transformation point. We plug it in, and we plug it in. So that's going to be 2, -5. So 2, -5 would be your new point, and the transformation would be 1/2 times 4 minus 3, and 2 times -2 minus 5. So that gives you -1. That gives you -9. So those transformation. Whoops, sorry. What did I do? -3. Oh, -4. Sorry. -4 gives us -2, so -5, -9. Sorry about that. Yep. Okay. So those are fun. Love those types of problems. Reflections, rotations, and slides, transformations. Those are your 3 different types of movements on a coordinate plane.